Hey, thank you, sweet tea. Maybe that did the trick. We'll give it a second, see if you guys didn't get kicked off there. Alright, yeah, it looks like I'm still live here. But my computer just hates watching it, apparently. That's crazy. If Firefox behaves any better. No, it just likes to eat CPU. That's fun. Opera, no, not me, Mindful. Is that still around as a browser? No, it was like years ago. Yeah, it just like sitting there. That's fine. Let's give it a shot. All right. So thank you for doing the syllabus quiz, and someone had reminded me that I totally forgot to post the other quiz. I'm sorry. Uh, so by the time it was the weekend, hopefully you saw the Discord chat. I wasn't going to post it to make you guys do it last minute. So we'll successfully have a quiz this week after we talk about Chapter 6, and then it'll just be one over like all 6 to 7, or 1 through 7. Well, hopefully that'll work. Let me pull this up here, make sure we're on schedule. So we talked about classes in CIS 1500, so it shouldn't be new. But what I do want to cover, that if you hadn't had my course, is we're going to look at this idea of unit testing. And then, again, it's just a good recap to do classes again. So we'll do a little bit on classes and unit testing today. We'll talk a little bit more about it on Thursday, and then talk about Project 1. I think a lot of you have gotten Project 0 in already. That's good sign that things are working, up and running, and whatnot. Let me make this up here. Okay, that's not too bad. So that's a good sign. Just want to make sure all the tools are up and running there for the little hello world, and then we should be in good shape. Alrighty. Cool. So let's pull up NetBeans. So you can do this unit testing stuff in other tools as well. I'm just familiar with it in NetBeans. I've done it before with, what's the other one? Wow. Don't have enough coffee this morning, apparently. Let's see. Nope. Losing it. We can Google. Oh, Eclipse. That's it. We've done it in Eclipse. I've done it in NetBeans. It does not work in JGraphs, best I can tell. You might be able to get something going, but it's going to be painful, obnoxious, and annoying. So it's probably best just use a better IDE if you haven't switched yet. All right, cool. So let's start up a new project. Make sure it's in my GitHub directory. So this will make sure I can commit it here. Ooh, I'm at 62 already for my home directory. Whew. This is Chapter 6 review. Probably should close some of these other projects. Let's see. My poor little computer is sad. 0. How many project zeros can I do? All right, there we go. We found this. And we got our Java file. You know, pull out all these comments. If you like them in, doesn't hurt anything to have them there, but they just irritate me. All right, so this Java file, right, it has main. We're not putting the class in here. We're not going to do those private inner classes if we can help it. There's not really anything really wrong with them. It's just not the way we typically do things. So I'm going to add a new Java file. for a Java class. And let's call this one ball. Okay, so things about ball, right? We're going to have our properties, our attributes, and then we're going to have our methods, the things that we can do with it. So we're going to have a Boolean for is moving, because you can throw a ball, right? And then we're going to write our constructor, so public ball, where the constructor's name matches the name of the class. You can have arguments. In this case, this one's simple. We're not going to have any arguments right now. So this is just ball. The constructor's job, right, is to give your attributes values. So if you're not accepting them in the constructor as arguments, we need to give them good value. So is moving, we're going to say it's false to start. This ball's not moving. Okay, and then we're going to add two methods here. So this is a public, we'll just call it a void method. Right? We don't really need to return anything here. We're going to say throw. Toss, how about toss? Throw is a reserved word. I should remember that. So if we toss the ball, then is moving will be true. And then we'll add a public void catch. Toss, catch is reserved too. Receive, no, that's toss, and it's another good word for catch. Catch me, why not? I got nothing better. Captured. Capture the ball, I like it. All right, capture. Thanks, Scholar. And we'll set is moving to false. Okay, so nothing super exciting here, just a silly little class here for some basics. The idea, right, we have our attributes, and I should say that it's private, right? It should default to private for me, but it's always nice to be explicit here. So private, Boolean is moving. I like putting constructors as your first argument. I also like attributes at the top. Some people like attributes at the bottom. I don't really care one way or the other which way you guys do it. And you're seeing my curly brace habit showing up here again, but we can format automatically. That's Alt-Shift-F, and it'll auto-format for you. So it makes life easy. It'll put the curly braces wherever it wants it. Okay, so again, the class is not very exciting, but this is just, we're going to have some values, and they're going to change based on these public functions. We could also have private functions, right? That we are just helper functions internally, but we don't need any of those right now. So your public functions here, your public methods, are your interface. Okay, this is how we interact with the ball class. Right? So someone using the ball class doesn't need to know our details, right? They get to interact with us in that abstract manner, in that all they know is we have these public methods. When we use scanner, we don't actually know how scanner works to get keyboard input, right? I'm sure we could go look it up, right? It's open source, but we just know we call the method and it does the thing for us. Same thing here with ball. That's the idea of this abstraction, right? Is that they get to interact with our public interface. Okay, and we're encapsulating all of our details, everything about ball here. So is moving. You know what? Why don't we add like a description? So let's add a private string for, I don't know, description. Yeah, why not? And then let's accept that description here. So like you might have a soccer ball, right? So we're going to say, now if I'm a big fan of doing this. Mr. Gaddis was not as big of a fan as I was, but that's okay. So because when you're calling the method and you get that little pop-up IntelliSense thing, it'll give you the name of the argument here. So this should be nice and meaningful. Don't use D. D is bad, right? Because it's not going to mean anything. Yeah, you can put in the Javadoc stuff, but just put it in the code, right? It's not going to hurt anything. So remember, we need to say this dot description is the description that I was given. And notice this one now turns purple, and this one here is white, like my white parameter here, the argument here. That's how you know you're doing it right. Okay, this color coding is pretty helpful. So the purple are these class level attributes. Should probably make my phone quiet, shouldn't I? How do I do that? I got a button for that, right? Okay. All right. So you can give it a description, but I don't have any way of getting it, right? This idea that our attributes will typically have set or get methods, the accessor or mutator methods. That all rings a bell, I hope. I miss seeing people like nod at me, but that's okay. So if we have a private attribute, we need a public way to access it if we want to show them what it does. So we're going to write public, so this will be a string get description. And all we do is return description. Okay, and the same with is moving. Public boolean is moving. Return is moving. And format. Right, put this back in the right lines. So this way we have public access to get that current value. So if you give an argument in a constructor and you don't have a set method for it, it's essentially like a, not exactly, but like a read-only value. Depends on what you're doing internally. It's possible we could change description other places, but the way that we're using it, we're saying, hey, give it to me when I get constructed in the constructor, and I'm not going to change it. So it's a read-only value here. So this idea, I could say, hey, it's a soccer ball, and I could toss it or kick it, I guess, or then capture it or stop it, block it, whatever you want to call, right? And it'll change this is moving attribute. But description's not going to change. Okay, so we'll set that. If we want people to change the description, it's totally up to us. It's how we want to define how people can interact with this. If we want it to change, great, we'll add a void set method for it. And we could have a void set description that takes a string description, and this dot description equals a description. Right, we could do that if we wanted to. Totally up to us. Again, the format, however you want to decide your class should be used. Okay, does that make sense? This is nothing new, I'm hoping. Just some reiteration. One other thing, now this is sort of silly at this point, but if you have a set method, you typically want to use the set method up here. We'll just call set description given description. A lot of times our set methods will do some sort of sanity checking, like, hey, is a value between a certain range or whatever we happen to do here. We're not doing that for description because we're just going to assume you gave me a good description, and I can't really enumerate the list of valid descriptions for a ball, but that's okay. So using the set methods in your constructor is great. I like that. No, we don't want to do any of those. Why would we want to do those? Okay, those were not helpful. Thanks, NetBeans. Okay, we all right so far? Nothing too crazy? So now we can use ball, right? If we want to make a ball. The ball, like soccer ball, equals a new ball. And this one is a soccer ball. It's going to be silly to toss a soccer ball, but you could also toss it, right? We could toss, and then, print the ball is moving or something like that. I don't know. The ball is soccer ball that is moving to string is moving. We probably shouldn't name an argument the same as a method. It should be it is moving. That's terrible. I'm sorry. It is moving. Right? Sure. And hopefully our ball moves. Oh, the ball is true. Oops. Is okay. All right. If soccer ball dot is moving, get is moving, we'll say it's moving. Else someone captured the ball. And those are exciting. We should do some exclams. Why not? All right, the ball's moving. Hooray, we tossed it. Okay, so we tossed it into play. The ball's ready to move. Or I guess we could even use like the soccer ball. So we could use description, yes. Soccer ball. Dot get description. I don't know, or what, the plus soccer ball get description. We captured the description. Oops, I didn't want to cut that. Okay, that's all right. Just moving this around a little bit, but just trying to have some fun. The soccer ball is moving. We probably don't need to capitalize those, do we? Okay, cool. And then, I don't know, just for fun, I'm going to copy paste here. Feel a little bit bad about myself, but so this is the sort of thing you would do when you were testing your code, right? Because you want to make sure that the code you wrote works, right? Hopefully everyone's nodding along. I think it's working okay. Just start like adding me at Discord if it bombs here, because I think it's going okay. But you guys got quiet. You're probably all getting coffee, right? Okay. Let me do this here. Oh, where's my poll? I'm just having one of those days. Yeah, it's not working. Hydrate, thank you. Okay, cool. So real quick, new poll. How are you feeling about classes? Is boring review? Is good review? It's a class. Ready for testing. All right, so just throw a poll out here. Like, so you don't need to be following along writing the code yourself. Definitely not worth trying to type along here. But just the idea, you can always come back to it if you want to try the code, or I'm going to post it all on GitHub anyway. So yeah, I don't think you need to be like writing the class along. We'll get to the unit tests a little bit. That'll be new. But so in Twitch chat, you should see a little poll there asking how you feel about classes so far. I just want to make sure we all have like a nice level set. This is what we expect to do with classes. Sorry if it's boring. We'll move on to the good stuff in just a minute. All right, cool. We got a couple of votes. Hey, it's like it pops out a new. This is good review. All right, awesome. Hopefully one person's ready to move on. Cool. So good review. Good. Thanks for letting me know. Yeah, so just working with the class. So this is what we typically would have done to test and see if it's doing what we expect it to do, right? So you write a class, we know, okay, it should do these things, let's try it here, and we'd have to do it all in main with these system out print lines and whatnot. Which is okay, and it's definitely good to test your code, right? You don't want to turn in code you haven't tested, right? Any code that's worth writing is worth testing. I promise you. Promise you that. Right? Don't let anyone tell you otherwise. It is worth testing, because you have to know if it's doing the right thing, right? Otherwise, why bother writing it if you don't care if it works or not? Now, it turns out there's a better way to do this, because it turns out people are kind of bad at this sort of thing. And nothing, there's nothing wrong with this. But imagine we were to change ball down the road or add other features and whatnot. We'd have to go run this again and look at it and try and remember what it's supposed to do. And it's just not ideal, right? Because it's easy enough for us to miss certain things. And ball's not all that complicated. We could have a more interesting class that actually has like some arithmetic somewhere, right? That would probably be more interesting. And then we'd have to check the arithmetic and make sure the arithmetic was right. Okay, so let's do that. Let's add another class. Let's do, this is a, what do we want to do here? This will be item for sale. That's a boring example, but it's It's okay. So our item for sale, right? If we're going to sell things, right? We're going to have some attributes like a price and probably a string for name. You have a name and a price. So really much else to it when we sell things. Maybe a quantity, right? That's an int quantity. Okay. So let's make this easy here. Let's just have a constructor that accepts all of these arguments. I'm a big fan of taking arguments in a constructor. So a name, let's do name, double price, and int quantity. So we'll accept all of these things. So this name is the name. This dot price is the price. Now price might actually change, right? We might want that one to be changeable. Now you don't often change the item. Like once you're saying, hey, I want to sell this bottle here, right? These bottles from SodaStream are overpriced in my opinion, but I don't sell them. I don't make them. I don't manufacture them. I just consume them. So maybe they're priced just fine. But I feel like they're really expensive for a plastic bottle. Okay. Now they might want to change the price on it. So sure, we'll have the price accept here, but we'll also write a set method for it. And then the int quantity, we'll set to quantity. And that's, nope, that was wrong, sorry. This quantity equals the quantity. Okay. So if we want price to be able to change, we're going to add a void set method for it, set price. Double price. Now in here, we probably want to do some sanity checking. Right? This is probably a good opportunity for us to do that. Because if my price is less than or equal to 0, maybe it's less than 0, I guess, that's probably no good. So we'll set this price 0, sure. It's probably still a bad place to be, but that's okay. Otherwise, this price is the price. And this is the sort of logic I don't want to have to repeat here, so I want to use set price in my constructor. Right? I don't want to have to redo all of this logic and say, hey, negative is not a valid price. I'm not going to pay people to take this stuff. It's not garbage, right? You're not paying someone to come pick it up for you. We're going to use set price on the price. We could also do that with quantity, right? So pretty much the same thing. We're going to change the word quantity here. Now, do be careful when you copy paste that you get the right thing. It's easy to mess that up. Oh, that's an int, isn't it? Quantity. Okay, I think I got all the right ones here. So set quantity, if it's less than 0, set it to 0, otherwise we take it. Right? You can't buy a negative number of things. Okay, so those ones are in good shape, and then we need to use set quantity up here. Right? So we'll sell a SodaStream bottle for some ridiculous amount of money. I only want to buy one of them right now because I don't need empty ones. Yeah, we're just talking about using classes right now, and then we're going to get to the unit testing in just a minute. So that one, we'll have some time near the end for you guys to practice that. That one's new. Name. So if you want, this one's a helpful hint. If we set it once, remember we have this final keyword in Java we could use, so it can be set once and never changed again. We could use that if we wanted. These are not helpful for us though. No, none of those are good. Okay. So setting name to final, sure, but we don't need to right now. It's just going to make sure we don't change it outside of the constructor again, which is handy, but that's okay. All right, so now we need all the gets, right? That's just expanding. All right, so let's add some gets. Sometimes you get some auto. Eclipse is good about that. It would generate some get methods for you. Can we do that in NetBeans? Beans. All right, get method Java. Maybe there's a way. Aha. auto generate get setting constructor functions and netbeans. That looks like a win. Point the cursor where you want the generated code. Alt insert. Insert getters and setters. Let's try it. Let's see if it works. I'm a big fan of that. So I want to insert. All right, I'm missing it already. Alt insert or source insert code. Source insert code getter. I love it. Look at that. That is so cool. It works. I didn't have to write any code. I'm way too excited. I shouldn't be that excited, but that was so cool. I don't show anybody this in 1500 because you're not allowed to use shortcuts there, right? I mean, you could, but you have to do it by hand a few times to really appreciate how amazing this is. You know, sure, it made 6 lines of code for me. It's not all that amazing, but how cool! I don't know, it's the little things. Okay, so now we got some gets. We have the 2 sets, and we have our constructor. Okay, now we need to do some arithmetic. Right, so your total cost is your price times your quantity. Is that correct? So if I'm going to buy 10 of these things, it's 10 times the price. I think I'm doing my math right there. Yeah, I made pancakes this morning for the kids. I did not get any yet because they were going to eat all of them. I might have to go make another batch because I really want pancakes. All right, so sets and gets, those are the boring things. Some actual business logic sort of stuff here now, right? Price times quantity is your total cost for this item for sale, right? And that's probably a double, right? Because our price was a double. So double, get total cost. We're going to return price times quantity. All right, now we have some business logic. It's not anything super fancy, right? But we're getting there. Let's see. Okay, sugar's good. I think we're in good shape. All right, sorry. Okay, price times quantity. Posture check. Thank you. I'm slouching terribly. Get this bad boy out. Dad joke. You guys are awesome. Yes. This is getting boring, right? We need a dad joke to lighten the mood. Now, I forget which ones I told to which class now, because I get so confused like that. All right, but you guys liked the math jokes, math-themed jokes, right? I think you were fans of math jokes. So I read, you know, as everyone gets upset and tensions get high with all the politics and whatnot, and everyone seems to have an opinion. And like, I'm really sick of people who don't know anything giving their opinions. And you know, because really, if it doesn't have 3.14, it's just an onion. That was okay, right? That was decent. All right, and then I owe one to you code. Let's see. That one? No. Man, I have to go way far back. You guys are stretching this. No, I did that one already, right? Ah, when is a door not a door? When it's a jar. Yeah, so what return does is when you call this method, it's going to give you that value. So like in here we said, hey, get is moving. So get is moving. If you go to this navigate, you can go to implementation. It's going to return that true or false here. So return is going to give you back that true or false. So I can use that value that's being returned here and I know it's going to be true or false, because get moving is going to return that Boolean, so I can use it inside of an if. The get description returns that string. So I know it's going to be a string, so I can just substitute it in here, and I'll get whatever string. All right, so our item for sale. Okay, mostly boring stuff. But finally, we have some interesting get total cost. Now, I'm going to show you the better way to test here. So I don't need to do, a lot of times, we might call this like a driver code. I think that's what Mr. Gaddis calls it every now and then. We're testing out the code, we're driving it. Sure. Right. What I'm going to do is I'm going to right click on it. I'm going to say navigate. And I'm going to say go to test. So at the class, you can do it pretty much anywhere in here, I think. I always do it right at the class because that's what I've gotten used to doing. So navigate, go to test. And NetBeans says, oh, do you want to create or update tests? And I say, yes, please, NetBeans. And it's going to do a bunch of stuff. Now, this part here, you want to go use JUnit 4. There's a newer version, and it's just weird and doesn't work very well for some reason, best I can Google. I spent like half an hour messing around with this, and most of the recommendations I found online said just use version 4 and you'll be fine. So okay, so we want to make sure you pick version 4 for JUnit tests. Okay, then all the other stuff here, we don't need the initializer, we don't need the finalizer, so don't worry too much about that. We want default method bodies. That's helpful for us. Again, we want the computer to write code for us, at least the boring parts. Right? We're going to do the interesting parts. On access levels, this should all be fine. Don't worry about that. We're not doing anything super fancy yet. Okay, so to make sure you change it to JUnit 4 and hit OK. And what it does is it makes a new package over here in test packages. And now I have a new Java file. And this Java file has a bunch of stuff in it. It is importing this org JUnit test and org JUnit assert. And we're going to use that here. We don't care about the constructor. We care about these at test. This is that annotation. So when we run our code, it's going to look for anything annotated with at test. Okay? And we get a bunch of tests here, right? We get a test set price, we get a test set quantity, we get a test get price, get name, get quantity, and get total cost. Okay? Because what it's doing is it's generating a test method for every public method of ours. So it saw a set, so it gave us a test set. It saw a set quantity, it gave us a test set quantity. On and on and on. And that's good. What we're doing here, this is called unit testing. So we want to test at an individual unit level, a small level, that our code does what we expect it to do. And what we're going to do is we're going to make the computer do it for us. Okay? Now, most of this is nonsense inside of it, so don't worry too much about it here, because it is not all that helpful. Some of it is, okay? So I'm just going to erase it here because it's easier to explain without the starter code. We're going to do this AAA format. Okay? It stands for arrange, act, and assert. This is just a convention. There's no hard, fast rule about this. It's just a convention that I'm quite fond of and people in the industry are fond of. And if everyone does a similar thing, it just makes life easier for everybody. Okay? So the idea is we're going to arrange all of the things that we need for our test. Then we're going to act. We're actually going to call the code that we're testing. In this case, we're going to check on set price. And then I'm going to assert that what I expect to have happened did happen. Right? The same thing like we did with ball here. We said, okay, hey, if I toss it, I should get it's moving or someone captured it. And if I capture it, I should get it's moving or someone captured it. And I know when I toss it, it should move, so I should get the first one. And when I capture it, it should stop, so I should get the second one. Right? Because we wrote the class, we know if I do this thing, this is what I expect to have happen. Okay? Same thing with our item for sale. So we're going to arrange everything first. So setting the price. So the first price, I'm going to say double expected price. Now, I'm a fan of calling these things expected if I'm going to use it in an assert later. So I'm going to say, hey, I expect the price to be, I don't know, let's do 4.2. Okay? So if I give it a price of 4.2, later the price should be 4.2. Right, so that's my expected price. Okay. Then what I can do is I can now actually call some code. This one, there's not a whole lot of setup here. Okay, so this is we're arranging, and then we're going to act. We're actually going to call the code that we're testing. So I need an item for sale, item, equals a new item, item for sale, and then item for sale needs a couple things, right? We need a string, a double, and an int. So sure, string, I expect the price, and 0, right? Doesn't matter. Because we're not testing the name, and we're not testing the quantity. We're only testing price. Now, it's a little silly because I know that it's calling set from within the constructor. So I feel a little bad that I didn't call set again, but sure. I mean, I'm not going to go too crazy here. So this is the code that will set the price, right? Because I know the constructor, again, you can use this navigate, go to implementation. This is super helpful here. You can navigate around your code. Go, come on, go. Go to source. Okay, go to source. Sure. Go to source, sorry. Right, I know we're going to call set price. Okay. So I've acted, I've called the code. Then I also need now a double actual price. And the actual price is my item dot get price. So this is what the code is actually returning here. Okay, so those two things. So we are acting, we're calling the code, and then we're getting the actual value from it. Then we can assert. So if everything worked right, my expected price should equal the actual price. So it's assert dot, assert equal, here we go. So assert equals, that I expect these things to be equal. Now, the funny thing is, when you're using doubles, remember Java's kind of bad at math, and sometimes you get those like trailing 0.1 millionths off of things. So when you compare doubles, you actually can give it a delta to say, hey, it should be within a certain range. In our case, we have an expected price, an actual price, and I'm just going to say, as long as they're within like, I don't know, whatever that is, a millionth of each other, we're fine. We didn't add or subtract anything, so it should be perfectly fine. Like, we don't necessarily need this here, and it should be okay. But most of the time when you do an assert equals with doubles, well, when using doubles, use the delta to say they are close enough. Does it make sense how that this is like, it's close enough because maybe we did a funny thing here? So when we do our total price, this is going to be helpful. Like when you multiply a double, right? As long as it's within, like, we're not writing a banking application, so don't worry if you're losing a millionth of a penny here. We're not banking. Yeah. Well, I don't put anything on D2L. It all goes in the course GitHub repo. Snake. So you can go get all that. I should go and commit, I guess. Let's go do that. Find GitHub here. Maybe. Maybe. Ah. Okay. Yep, so here's a bunch of chapter 6 review. 6 review started. Commit. And push. Right, commit, so your local repository has the copy. Push so that the github.com origin central repository has the copy as well. And you guys have a link to it in D2L, or you can always just go find me on GitHub. But mine, view on GitHub, right? CIS 2151, winter 2021. Okay, so it's all out here for you to take a look at later. Okay, thanks for reminding me to commit. All right, so we did our arrange. We said, okay, these are the variables I'm going to need for my testing here. The act, I'm actually calling the code that will do this thing. And then getting the actual value back. That also belongs in act, like the get. So this is what the actual value is here. And then I can compare them. Now, some people like to put this right inside the assert. The problem I have with that is it's slightly harder for me to debug. Because I can put a breakpoint in here, and I can see what value I get back. I could put a breakpoint in the assert equals, but then like stepping through it just gets awkward. So I'm always a fan of putting it here because it's easier, right? In terms of seeing what the value is if it goes wrong. So that's all. There's probably nothing wrong with putting the get price in here, but that's okay. All right, so let's try it. So I'm going to right click and I'm going to say test file. And it should think for a second. Oh, we get a bunch of errors, right? But because yeah, these were bad, right? The starter dummy code is bad. Okay, don't worry about that. But my test set price, notice we get a nice green check mark here. It worked. Yeah, so if I want to put a breakpoint in, just come over to the line numbers. And then instead of test file, I want a debug test file. And it's just like the debug mode regularly. And you can actually put breakpoints over in your other code too, which is fun. Okay, so we're right here. Right? We don't know what price is yet because we haven't got the actual price out. But I could even step into, and now see it goes into my item for sale. Remember this is my instance, so I see it's a nothing name, 0 quantity, 4.2. I'm going to return that, step, and step. So now I can see what the actual price is. Yeah, breakpoints are amazing. Definitely want to use those more. Okay, so that worked out well. So this AAA format make a little bit of sense. We're setting up the variables, calling the code, and then making sure that what I expect to have happen did happen. That's my assert. All right, so let's write the rest of them. Yeah, it's going to take a little bit of practice, but the idea is now that the computer can do a much better job at making sure things match than we can. And once we have our tests done, what we do is anytime, it'll be available on Twitch, and I'll export it out to YouTube as well, Yogi. So anytime we make changes, we can run these tests automatically. There's a whole set of tools called continuous integration engines or something. I forget. It's continuous integration, probably engine or software or something, where it will run the tests for you. And any tests you have in your code, it will run, which is awesome. So these are just unit tests. You can get bigger tests that actually test the components working together and all sorts of integration tests, but go take the software engineering class, learn more about that. We just want to make sure our class is doing the right thing. So we're going to finish writing out our tests. Okay, so again, I'm just going to take out most of this gibberish because for now it's not as helpful. That's okay. We'll get back to it later. Maybe the next time it might be helpful because you can pick and choose which some of that stuff you want to keep. All right, for setting quantity. So there's some different schools of thought of writing tests. Some people, I haven't had a chance to show you yet, think you should write your tests first and do test-driven development, which is absolutely fantastic. If you can, that is awesome, and it's really satisfying to be focused that way. I think on Thursday I'll show you guys that. Most people, I don't even, probably most, will write their tests after. Because to have the discipline to do test-driven development is kind of difficult. Yeah, exclam class there, GZB. All right, so for set quantity, we're going to do the same thing. We're going to arrange. So I have an int expected quantity. So if I want to buy 42 of those things, and then act, we're going to create that item for sale. Sale item equals a new item for sale. Plus name we don't care about, a price we don't care about, but the expected quantity, great. Oops, expected quantity, great. And then we're going to have an int for actual quantity equals my item dot get quantity. And then we can assert. So with this one, with integers, we don't need that delta. So we can just assert equal my expected quantity equals the actual quantity. Actual quantity. Nightbot's so helpful. Love Nightbot. I gotta remember to put more commands in there. Exclam command, I think, will tell you some of the other ones. All right, so I wrote this one. Let's see if test quantity works. Oops, I want to test. That's fine. Look at that. So notice these other ones passed even though they're empty. That's sort of sad. So that's why they had that fail in them at the end. Was it assert fail or something? Or was it just fail? Yeah, it was just a fail. Just to make sure that when you run the file, you notice you have a failing test. I think it's commands with an S, Scholar. Okay, so set quantity seems to be working. Now, we haven't checked out, yeah, there we go. All of the possible things that can happen here. Remember, we did some sanity checking here. So the only piece that we've tested now is really this line here and this line here. So when you're doing unit testing, there's this idea of something called code coverage. And what code coverage is what it is, sorry, I don't speak. We want to make sure that all of the lines of code will actually get executed at some point in our tests. So right now, for set price, we're only testing like half of it. So in terms of code coverage, we've tested half, because we've tested that this works, but we didn't test that this works. Remember, like if and else, those aren't really commands. I don't know. I don't know how you'd want to count that, but so, of two things that could happen, we only tested one of them. So we have 50% code coverage for set price. So a nice ideal, and it's sadly an ideal, is you get 100% code coverage. That every line of code in your class will run at some point in your tests. Now that can be hard to get to, because this is a nice small one. It won't be hard here, but as our classes get bigger and more complicated, it can be difficult to get to every single little piece here. Every little if else, every different section to get 100%. So it's a good goal. Sometimes it's just not achievable, and that's okay. The amount of time that it takes just gets bigger and bigger and bigger. So the idea here is that some testing is better than no testing. Right? So like if you can get to like 50% code coverage, that's way better than none. But to go from 50 to 75, you didn't get quite as much return on that investment typically as you did for getting that initial 50%. And then go from 75 to like 90 takes even more amount of time. And to go from 90 to 100 takes even more time. And usually you're getting less and less return each time. Again, it's more of like a software engineering sort of principle there. But I'll say we could always get 100% code coverage. But this is just class where we have lots of time, right? And you're not like getting paid or charging a client by the hour for the work that you're doing or whatever. So... but I still would say that any code worth writing is worth testing, because you want to make sure you did it right. So I'm a big fan of testing. But even if we did get to 100% code coverage, we're still not guaranteed that there aren't any bugs. So if you had me before, hopefully you remember that, but it's possible that we still have a bug and we just tested it wrong, right? That we did the wrong thing and we tested the wrong thing. That could happen, but testing will reduce the chance of bugs. Can't make them go away completely, but it'll reduce it. So we have test price and quantity here. Now what I want to do is I want to copy this whole thing, including that test annotation here, and I want to make another one. And ideally, the method names here are descriptive of what it's doing. This is with negative value. So if I give it a negative value, I don't actually expect to get back a negative price, right? Because my item for sale should set it to 0. So my expected price should be 0. And if I give it negative something here, I should get 0. Does that make sense? So again, just tweaking just those couple things, but I want to make sure that that code path, that if block, gets tested. Yep, I get a 0. So if I give it a negative value, I should get a 0 back out. I'm going to do the same with quantity. So you've got to make sure you have unique method names, right? So this is with negative value. So I should expect it to be 0 if I give it a negative value. And we can run that one. So now I'm feeling better because I have 100% code coverage of these sets now. Because both if and else are being tested. Right? This if and this else are getting tested in different tests. It doesn't all have to happen in the same test, right? So typically the idea with a test is you want to test one method, one thing. You can put it all in a single test, but then if it fails, it's really obnoxious to go and figure out what went wrong, right? We want the nice distinct little chunks here so that if it does go wrong, I know, oh, something with get price isn't right. And I can go right to the get price and figure out what's going on rather than having them all in one. So you can have multiple asserts. I don't think we're going to do that today. We'll probably do that on Thursday with multiple asserts. All right, so get price. We're going to arrange, we're going to act, and we're going to assert. Okay? So, you know, we actually, this getting price is sort of silly because we did the get price when we did set price because we had no way to check it without a get. So I'm going to say we've already tested get price. Does that make sense? So I'm actually just going to erase that because I don't need it. Because we did it, and we did a get quantity. Okay? Is that fair? We're not cheating because we already called those methods here inside of over here. We called get quantity. Yeah, definitely off to a great start if this is kind of making sense. Right? We want the computer to do the testing because it's better at it than us. All right, get name should be nice and easy, right? We're going to arrange, we're going to act, and we're going to assert. So arrange, we should have a string for like expected name. Expected name. Let's sell some coffee. Okay, and let's act. Let's make an item for sale. Item equals new item for sale, given the expected name. Nope, come on, expected name, 0 and 0, right? I don't care about the other values. And then I'll have a string for actual name. I love Minecraft emotes, that's awesome. Here's my item dot get name. Then I can assert equals my expected name and my actual name. Look at that. And if you do the naming like expected and actual, it's smart enough to pick it up for you. Again, I'm a big fan of not having to do a lot of typing. Okay, let's give that one a try. So if we make some coffee, do we get back out coffee? Awesome. It's working so far. All right, the last one now here is get total cost. Okay, so again, we're going to arrange, we're going to act, and we're going to assert. So for this one, I probably want a double item cost and an int item quantity. Quantity. So if the item cost is 4.2 and the quantity is 42 of them, then I'm going to have a double expected total cost is the item cost times the item quantity. Right? There's my arithmetic. Oh, thank you. I keep slouching. Bad at that. All right. So once we have that, then we can create that object. So an item for sale. Item is a new item for sale. And we can give it, I don't care about the name, right? So just something here, an item cost and an item quantity. Hopefully we did that in the right order, because I think it matched. It's a double and an int, otherwise it would complain to us. And then we'll have an actual total cost equals item.get total cost. And we can assert. And now because these are doubles, we're going to have that delta, right? So it's assert equal. Oops, assert equal. Wow, sure. My expected total cost and my actual total cost, and you know, as long as they're within like 100 millionths of it, whatever, but some zeros there, we should be fine. So let's try that one. And it passed. But if we don't have the delta, sometimes it'll be fine, and other times it'll fail, and sometimes it's just flaky. Yep, so that one failed. See? I don't know that number. So, oh, it's even telling us, hey, we should use the one that takes a delta to compare floating point numbers. Isn't that nice? So it's telling us use the delta. All right, so let's put the delta back in. So let me show you, just for fun real quick, if we change one of these, like 2 here, the error message you get is actually helpful. So this one failed. It said, hey, we expected 2, but we got 0. Isn't that a nice failure message? And you can open it up and you can see, like, hey, sure, item for sale, test quantity with negative at line 65. And you can get right to it. So it's pretty cool. So that is unit testing. You can do it in other IDEs. Eclipse, I know, works for sure. I've done that. NetBeans will do it. It makes the test package, and then they run separate. Again, the idea, we want our test code to be separate. So you want it in a different package. And what happens in like the real world is when you go package up your code to deliver it somewhere, you totally exclude the test packages projects because you don't want to ship test code along with your production code. Right? So in our pipeline, when we actually do our building and packaging and whatnot, we're just going to give them the actual project class files. And we're probably going to put them all in a big jar or something, right? But it excludes all the tests. So keeping it separate is also nice, where you don't have to have, hey, I've got a main method here, but don't actually run this thing over here, because that's not useful code. And then you don't have to have different mains. If like you want this main for testing, you run this main for actually using the code, right? If you were to actually build out these drivers. So this I'll kind of call like poor man's testing. Right? We could do this, and we could even do the exact same thing, right? Where we could say, after we've captured it, if... Ooh, hydrate, thank you. Uh-oh. Am I getting laggy? Maybe I am. More coffee. More coffee. Ooh, we're about due for a break. It's 11 now. But we could say if... So, after we've captured it, if it does not equal false, we could system out print line error should be false or something like that. But then we still have to go look at our output. Right? We still have to go manually run this thing and then look for it. Okay, I didn't get any errors. Good. So the poor man's testing can work, but it's still extra time, and it's not quite automatable. Okay, so this is poor man's testing. Poor man's unit testing. Unit testing. In this little block here. So if we can get code to do the tests, right, we can hook this up into those continuous integration engines, and the other thing that it does is it can hook into your source control. So this is completed tests. Is every time you commit your code, it can go run the unit tests for you out in the cloud on someone else's computer, which is awesome. Right? The idea that we'll push all the unit testing out at someone else. Because as you get more and more and more tests, right, ours run pretty quick. Right? But on a bigger project and an enterprise scale, these tests can take a little while to run. So if we hook that up to the cloud, and we push our code out, and then tests just run, it's fantastic. We can make that happen. And we can even get reports. It's really cool. You do all sorts of amazing stuff. Again, it's probably a little bit beyond what we're doing here. Okay? All right, why don't we take a 10-minute break, and then we'll come back in a little bit, talk about some other features of classes in Chapter 6. We'll do another unit test example, and then we'll probably call it a day. So let me try and find some music again here. Sure. It wants to open with groove music. I'm not super thrilled with that, but that's okay. Probably will work. Maybe. There it goes. All right, we'll come back in just a couple minutes. Let me put on their break time. Say 11:15. All right, guys, grab your coffee. Hey, welcome back. Maybe, unless it crashed. Had some problems with Stream Manager. Let's see. See if it's still going here. All right, it's working on it. Hopefully you guys got your coffee. It's thinking real hard. Yeah, it says I'm still going. Couple drop frames. Yeah, Winamp is a throwback, yeah. All right. Cool. All right, I think I'm back. Okay. We're good so far? So let me do another poll here. I know you haven't tried one yet, so don't worry. That'll be part of the project 1 here. But about classes and unit tests. I'm lost. Okay. Try it first, or ready to rock and roll. So go ahead, if you see up at the top of Twitch chat, there should be a little poll there for you. Let me know how you're feeling. They've got those really cool like clicker things you can do in the classroom and whatnot, so it's fun. Other conventions? You know, I'm not really sure. It's a good question. I mean, you can just write the tests and not organize them that certain way, and it'll still work perfectly fine. So it's really just a way of like organizing it. So if someone else wants to go and look at your tests, then they'll kind of know what to expect, right? You'll have a block, and a block. So just to make it easy for other people to go look at it is all. Excuse me. All right, let's see. How'd you guys do? Why does it open in a new tab for me? Like, I just want to see at the top of chat. All right, need to try it. Yep, for sure. Okay, rock and roll. Awesome. That's good. So if you had me last semester, hopefully that was familiar. If you didn't, that was brand new, and you guys are amazing for keeping up. So I'm impressed. It's a different concept for sure. Something to wrap your head around. Okay. All right, let's go back. Let's add another class here. New class. So I want to go over this example. We did this as a project for my class in 1500. So if you had me, feel free to check out. If you didn't, I'm hoping this is a good example of how a class can work with itself and its attributes. So this idea is, this was the Powerball. I did that wrong. Oh my goodness, there we go, refactor, rename. And I want this to be a Powerball ticket. So we did this little lottery project here where we were pretending to be a Powerball ticket, right? And the idea that a Powerball ticket has a couple of values, right? So it had int array for the white balls and private int for the red ball, right? And this Powerball is just a lottery. It's a big scheme for the states to make money, right? If the states didn't make money, they wouldn't offer it, right? The lottery is just a scam, by the way. I mean, people do win, but like it's designed to make the state money. So, and the people that they target to play are typically the poorest people who can't afford to play. Then they throw out these big jackpots, and people have big dreams, and like they think they're going to win. And sure, somebody eventually does win, but it's just a big scam. So I have strong opinions about the lottery. But anyway, the way that it works is you match your white numbers in combination, not permutation. So the order doesn't matter, right? So my first ball could be a 7, and as long as the winning ticket has a 7 somewhere in there, it's a match, okay? You get the grand prize on down. So a bunch of different prizes, okay? And odds, and they're terrible, right? Your chance of winning is very low, and if you do win, you pay a bunch of taxes on the money. So like someone says, hey, if the odds of winning are 292 million to 1, I could buy 292 million tickets and be guaranteed to win that grand prize. Well, the problem is the grand prize could get split, right? Someone else might also win it when it's 700 something million, so you might get half of that, and then you're paying 40% in federal taxes plus the state tax, and if you take the cash payout, you're not even getting all that money all at once. So you get like 70% of it in a direct cash payout. Okay, so again, it's just a giant scam. It's horrible. They do it because other states. It's just nasty because other states do it. We feel like we have to do it too. So that's sure. Your odds of winning anything, 24.9. Just winning anything. Ooh, wow. Still the same prize. So okay, yeah. Here's the annuity that they'll give you instead of the cash prize. Okay, sorry, I don't need to harp on that. It gets me upset. So anyway, they have 5 white numbers and a red number. The white numbers are 1 to 69, and the red number is 1 to 26, I believe. Yeah, I mean, you could run a big loop and wait until that happens. So, all right, so white ball and a red ball. So we're going to write a constructor, Powerball ticket. And we're actually going to write 2 different constructors here. The first one here, we're not going to take any arguments, and I'm going to assume this is a random ticket. The other constructor I'm going to write is going to take the values. Powerball ticket. So like you can pick the numbers, so we'll have an int array for white balls and an int for red ball. Okay, and I'll set my this white balls, the white ball array, and this red ball to the red ball you gave me, to the argument. Okay? Oops, that's missing a thing there. Okay. That looks a little happier. So if we don't give it numbers here, right, we need to generate them. So we need to use random, right? So random random equals a new random. Random dot. And then we're going to use next int given a bound, right? The max number here for a white ball is 69. So if we go to 70, we're going to get 0 to 69, which is not what we want. We actually want to get from 0 to 68, and then we want to add 1, because this is not inclusive. right? So 0 to 69. 69 will give me 0 to 68. And then when I add 1, I'll get 1 to 69. So I'll do that for my white numbers here. But I need to make sure there's no repeats. So you're not allowed to have any repeats here. So we had to do a little bit of checking there to make sure we don't get any repeats. So I'm going to say for int index is, oh, we got to size it first, right? So white balls equals a new int array of size 5. Right, so now I have space for it. Okay, index is 0, index is less than white balls dot length, index plus plus. Okay, so first thing we're going to do is we're going to set that value. So white balls at index, right, is random dot next int from 69, 0 to 69 plus 1. Okay, and then we want to check. We're going to make sure we don't have any repeats. So now I'm going to do another loop and check. And really, I guess this could be a do. I'm not sure. So the index, that's the index notation inside the array. So array at index 0, array at index 1, array at index 2, array at index 3, array at index 4. Because we are going to have 5 values inside of this array. Indexes 0, 1, 2, 3, and 4 for the 5 values. Remember your indexes, we always start with 0. That's why project 0, it's kind of funny. It's a programmer joke. Yep. All right, so we'll do the first one, and then we need to make sure that we don't have any repeats. So we can check, there's a couple ways we could go about it. Yeah, I hate when people use I. It's not that much harder to type index, and then I always get confused on I because it looks like other letters, and I have strong opinions about things like that. But I is fine. I prefer index. All right, so we picked a number, and now we need to make sure there's no repeats. Let's see. Well, we could do. Let's do this. Let's do this. So instead of saying it equals a new int 5. We'll say it equals, you see this initializer, 1, 2, 3, 4, 5. New int array. There we go. Okay. So instead of telling it size 5, I guess we could leave the 5 in there. Oh, no, we don't. We don't tell it 5, we just give it 5 values. So it's going to set them all to 0. Okay, and let's do this thing. While, I don't even like that. So if we start them off at 0, we want to repeat if we have any duplicates. Yeah, just check with a little loop, see if they match. All right, sure. This is. It shouldn't match itself. I am having the hardest time. This should not be so hard here. I could just go plagiarize off myself. Go do that, right? Why not? Let's go do that. 800. I'm just gonna go find whatever I did. I think we used a loop, right? Is that project 3? Source. Powerball ticket. There we go. Look at that. Oh. Okay. Sure. Why not? Why not? And look at this. I'm going to cite my source. Look, copy the URL. From paste. Boom. Done. All right. So, sure. It's not that. I'm not the most proud of this, but it gets the job done. So if it matches, do it again. If the second one matches, or the third one matches the first or the second, do it again. If the next one matches those, do it again. If the next one matches any of them, do it again. Sure. Why not? Who needs a loop inside of a loop when you can do 4 separate loops? Okay. So that's our random ticket. And then red ball also, that's right, red ball. Red ball is equal to random.nextInt, and that's 26 plus 1. Was that it? 1 to 26? Is that right? Really should remember. Isn't there like a how it works? How? There we go. Nope. How? Yeah, 1 to 69, 1 to 26. Okay, I got it. I got it. Okay, so that set it up. Now, we're assuming you just did the right thing over here. Okay? This array copy is probably actually, maybe not the best idea, but that's fine. We'll get over it later. So anyway, this is not the whole thing we wanted to do. The reason why I'm bringing up this example is what's interesting about this is we can have a method called getWinnings that accepts another Powerball ticket instance. We're going to call this the winning ticket. Okay, so what happens here is I'm going to tell you how much money you won if you give me another instance of a ticket. And this is why classes are amazing, right? This idea with object-oriented programming is I'm going to say, hey, a Powerball ticket is a noun, it's a thing, right? So it's a potential class. And in this case, yes, I want it to be a class. I have all these details, right? I have the white numbers, I have the red numbers, I have whatever, and each ticket can have its own set of numbers. Right? People will buy millions of these tickets and waste so much money. It's just sad. But okay. And everyone will have different numbers. To get your winnings out, you have to compare your ticket to the winning ticket. So, right, I have this dot white balls is mine, right? And then the winning ticket dot white balls is the winning ticket's white balls. Snake, are you just trolling me now? You're just messing with me, right? You're trying to get me upset? All right. So if I want to compare myself to the winning tickets, this one's actually pretty easy. So I'm going to have an int number of white matches is 0. And now I'm going to loop. So for int my white ball index is 0. 0. My white ball index is less than white balls dot length. Balls dot length. There we go. My white ball index plus plus. All right, that one might be a little bit long, but that's okay. Right, you guys get the idea here. So for every one of mine, I need to check every one of theirs. For int winning white ball index 0. Winning white ball index is less than the, again, it doesn't, white balls dot length. I don't need to check theirs because we're the same, right? Winning white ball index, winning white ball index plus plus. All right, that got awkwardly long, but that's okay. So I'm going to check if my white numbers, white balls, white balls at my white ball index is equal to the winning ticket dot white balls at the winning ticket white ball index. See, so I think that having those big, ugly, long variable names is useful. Because it's really clear like what this one is. White balls at my white ball index. Winning ticket, white balls at winning white ball index. Right? To be nice and descriptive. Like, if you're going to use long variable names, just own it. Don't be embarrassed. Okay? If they match my number of white matches, plus plus. And I'm going to check my first number against all 5 of their numbers because we match in combination, not permutation. So the order doesn't matter. It's not first and first, second and second, third and third, fourth and fourth, fifth and fifth. It's mine anywhere in theirs. My second one anywhere in theirs. Right? So we just do 2 loops. Loop through each one of mine, checking each one of theirs. Okay? And then I'm going to have a Boolean for red matches. And I'm going to just check my red ball is equal to. So this one looks a little bit funny with all these equal signs, but it's okay. The winning ticket dot red ball. So this is just a Boolean. It's either true or false here. Hydrate, thank you. Dude, how can you not have money? Just win the lottery. Mindful marijuana. You are on a roll today. That's right. I meant I've got a tool I was trying to use. I hadn't tested it yet to like highlight chat and get the chat on the stream here. But $1.50 and a scratch off, amazing. That's cool. That's a real winner. Yeah, I was at the gas station and I saw a guy buy a $20 scratch off ticket and scratched it off there and scanned it. It won $50. So he bought 2 more. And he scratched them off. And he won like $10. So he bought another one, scratched it off, and lost it all. Lost all the winnings because he just kept buying lottery tickets. I'm like, dude, just stop. Yeah, I've found a tool for it. I just didn't actually add it to OBS yet. So hopefully it'll work well. Yeah, I don't know. It's like casino games. They like to keep you in the casino because the longer you're there, the more you're going to lose typically. It's a sad industry, just a really sad industry. Okay, anyway, so once we have the number of white matches and the red matches, we can go, and I'm just going to cheat again here. We have all this, because that's not the interesting part. Like, how we compare ourselves to the winning ticket is the interesting part. Boom. We'll copy paste some code. Okay. Did you know in Java you can put in underscores inside of literals, hard-coded numbers? How amazing is that? So like you can see, hey, I'm just saying you win $1 billion. I don't care. It's not going to happen. Or, maybe it will in 292 million tries. And we're not paying taxes in this fake money. Okay? So we'll just go on down and return the right value. This is how much you won. This is how much you won. This is how much you won. %92 is less than breaking even. Yes. It looks right unless you understand math. 92% of people who come here are winners. They won something one time. It's just sad. I'm sorry. Anyway, okay. So the idea here is I'm going to take my instance of Powerball ticket compared to another instance of Powerball ticket. So that's the great thing about using classes, right? That this class can compare itself to another of this class. Right, so we kind of need to, we're stepping away as we start designing classes from this straight, here's a method, and you have to hand everything to the method. Because what happens is, when you call get winnings, you're already in an instance of Powerball ticket. So you already have your white ball array, you already have your red number. You just need what you're comparing it with. Okay? So it's a little bit different than doing and this is just one approach, right? You could do a Powerball simulator without using any classes at all. The reason we use classes, right, is because it makes more sense to people. And code is for people, right? That's why we have these nice programming languages. It's for people, right? If you look all the way back to 1500 and then go back to that terrible chapter 1 review, people used to write code in assembly. I actually recently took a class in assembly. It was a prereq I had to do for the doctoral program. It's a big pain in the butt to program in assembly. Like, you don't have any shortcuts. There weren't any easy ways of doing things, right? You had to do every single stupid step. Now, you can do some cool stuff with it, and you can be super fast, because you don't have any of the overhead of having to run the Java virtual machine, but the programming languages are for people. So the code here is for people. So the reason we have object-oriented programming is because it makes sense to people. Because we deal with objects every day in the real world, right? Like, this is my cup. I drink from the cup. I put coffee in the cup. I drink from the cup. I pick the cup up. My cup is blue, right? It has attributes. It has functions, methods, the way we interact with it, right? So again, when you're designing a solution, anything that's a noun could be a class. And you don't have to go completely crazy overboard and make every single noun a class. There's definitely a fine balance there. But the things about the noun, its attributes, right, become those private instance members. And the things that you do with it, the verbs of that noun, the things that the noun does, are its public methods. So we write and we use object-oriented programming because it's kind of a natural way for us to think of things. Yes, the cup is blue. Blue. I got this for Christmas and I love it. It's huge. What is it, like 36 ounces, they say? It's like almost half my coffee pot fits in here. I've been drinking the same one, and it's not even empty yet. It's just amazing. Okay. Here, I should cite this one again. I'll just move it here. I'm just gonna move the whole thing. I'm gonna put it up here. Okay. Excuse me. Right, so that class, then, we need to think about in terms of a class and how a class can interact with other instances. Hey, yeah, go ahead, donate to the Student Scholarship Fund, Snake. Though I think you can get the emotes for free with the channel points. At least unlock it for like a day worth or whatever. All right, any other questions? I think we're about good to wrap up. A couple minutes early now. We do have our study group later today. Right, I think that should be out in the calendar. 4 p.m. today, right? 6 p.m. Wednesday, 4 p.m. Thursday. Okay, make sure you get your project 0 in. We'll talk about project 1 on Thursday. We'll do that one on Thursday. I want to talk about test-driven development a little bit more. Yep, and then I'll do it on Thursday. Yep, so 4 to 5 today. Fantastic. 6 to 7 Wednesday, and 4 to 6. So I will remember. I'm going to do it early, and like you can set all these things up if you're more prepared to have that quiz over chapters 1 through 7. Yes, so forget it from last week. Sorry. So if you make it to a study group, you'll get an extra point on the quiz. So I'll have that. It'll cover everything 1 to 7 in this sort of review session as we're working our way through getting into the new stuff. So I know unit testing is probably new for some people. So we're getting there. Then after Thursday, we'll move on to new stuff, second look at classes. And we'll get a little deeper at classes and objects and do some fancier stuff with them, which is really cool. Okay? So project 1 will be all about classes and unit testing. We'll pick up second look at classes and objects, do a project using some of those additional cool things about them. And then project 3 will do probably some text processing and inheritance. Maybe some text processing. We've got to work on that still. So we're cruising along. It's been a lot of fun. I'll be hanging out in Discord later today for office hours. Let me know if I can help you guys with anything. Definitely get Project 0 in. I want to make sure everyone has their tools up and running, ready to go, understand this Git thing. I know it's new. It's going to take some practice. That's why we practice it, right? So if you have questions with that, let me know. I've done 2 or 3 screen sharing sessions with people already, gotten stuff installed, gotten them up and running with Git. Awesome. Yep. And we should be good. All right, gang. Let's see. Is there anyone else fun online? Let's see. Who else is online? Let's see. I don't know. It's kind of a weird time of day. Nobody knew. So I don't know. Just go check out somebody and have some fun. Snake, you're a hero. You're a hero. Thanks for donating to the Student Scholarship Fund, my friend. All right, you guys. Take care. I will see you on Thursday then. I'll tell you another dad joke while you guys all leave. This will drive the crowd away. This one's just for Snake. It's all his fault. Did you know a bicycle can't stand on its own because it's too tired? That probably wasn't worth staying for. All right, this one. You know, you get in the Guinness Book of World Records for all sorts of weird things. Like some people like to eat stuff you shouldn't eat. And someone got in there for eating light bulbs. They could just eat a big pile of light bulbs. And he said, oh, it's really nice. It just makes for a nice light snack. All right, guys. Take care.